Okay, great. So yeah, today's session would be more on a dev tool rather than a particular technology. And the title is itself is an index, right? So we are going to explore all of this. Okay, yeah, all of these keywords that have been mentioned. But before starting, I want to ask, like, how many of you are working professionals? Very good. Now excites me. ML engineer, AI engineers, data scientist. Okay. कुछ गलत बोल दूँ ना मत, please. Okay. Okay, right. How many of you have trained the models, machine learning models? Very good, big crowd. And how many of you have deployed your models? Okay. One last, बहुत critical question. Have you used TFX? Okay, one guy. Falak Shah, Infocusp. Got it. Please, आप कोई सवाल मत करना. Okay. So yeah, so today's session, like, as only one of us, as you know, two of the people who are in the room have used TFX. I'm gonna set some ground to understand TFX, and it is good. We a lot of you have worked with the machine learning. So let's see with one thing. Imagine that you are working in a team, and your team is your team is working on something called as customer churn prediction. Right? Don't worry if you don't know this keyword. The important thing is if a team is working on a problem, you are trying to understand data, you are trying to work on algorithm, you are trying to clean the data, you are doing feature engineering, hyperparameter tuning, and at the end deploying model and making sure that your model is working fine. If there are 2 or 3 people in the team, हम साथ में बैठ के कुछ ना कुछ कर लेते हैं. Imagine 100 people working in a team. 25 India में, 25 are in US, couple of them are in Canada, or independent of geographical location. And out of that thing, few of you are using TensorFlow to develop algorithm, few of you are using Keras to build a model, and some of you are using PyTorch to build model. Just imagine how much problem will you face once your model passes the POC stage and you want to put into production, right? You start observing all this problem. First is lack of standardization. Even using a different version of TensorFlow can cause some problem. If you are at a 2.1 and 2.5, and if you put into production, it might cause a problem which takes a humongous amount of time to just find it out. Difficulty in scaling, definitely if you are working with a different dev tools, it is very hard to, let's say, patch things up. We have a different set of talent. If a guy using PyTorch and he does not know how a TensorFlow is coded, like, concepts are same, but the syntax are different, right? Though this creates a problem. Versioning issue, inconsistent data processing. I love NumPy to, let's say, do data pre-processing. But in some of the pipeline, you cannot put NumPy. It uses a different approach. And cost of combining different tools. We need different talent. We need to get different people who can, translate from, let's say, a NumPy pre-processing pipeline to a TensorFlow pipeline. And all of this combined incurs a huge cost when you are trying to build a pipeline. So what kind of solution do we need for that, right? So we need something which is standardized. So let's say if a team of 50 people, if I say that, hey, I want to use this tool. This tool has a specific way to, specific framework to write, specific set of tools to use for a specific task, and a specific version, you can avoid a lot of problem while you are, moving from experiment to production. Scalability, when you are combining different kind of tool, creating, adding different Docker images to work together, that's a headache. But if it's all the same with a different approach, it's easy to do. Reproducibility. This, let's say, reproducibility in the domain of machine learning is a big problem. Making sure that whatever runs you make, or whatever experiments that you do, if you're getting a different result in every run, it's hard to find a problem, right? So reproducibility is a big necessity, and consistency. And if you can combine these 4 things in a single product, don't you think it's going to add a lot of value in your team, a lot less headache, more faster experiment to production, and easier to maintain? How many of you think that if you have these 4 or 5 things, your life would be a bit easy as a machine learning engineer, right? To address this problem, a TFX was developed. A TFX stands for TensorFlow Extended. As the name suggests, it is built on TensorFlow only. This is a definition by Google, like TFX is a Google production scale machine learning platform based on TensorFlow, right? If you just read it out, sometimes it doesn't make sense. We are lucky that everyone is experienced, but if I'm explaining to a college student, like पहले बताओ Google production scale ML platform, like these are itself are topics, right? So ये सब एक में कैसे combine हुआ, right? So if I need to explain TFX in simple words or pixels, whatever you prefer, it's a collection of libraries and some components that is there to make your life easy. Library offers a standard data processing templates. Components offer a standard way to build a pipeline. Right, so it is built up, and we are going to explore each and every, let's say, these libraries and components. By the way, I'm going to go a bit fast on this one because a lot of us are already familiar with the machine learning, so it will be easy for us to, just connect with it, right? So I hope you guys are visible, but this is how things are working with the TFX. So there is a standard, let's say there are 3 separate areas: data ingestion, training and analysis, and deployment. And TFX provides solution for each and every one of them. So if you are building a pipeline with TFX, it is much easier. If it's a simple, let's say, image classification model, you can literally build that production grade pipeline in a day, and even deploy it as well if you are a seasoned professional, right? So let's start with the first, that is the data ingestion part. So this is what the pipeline would look like if you use the standard components, right? And the first one is the example gen, which works as a starting point of this TFX pipeline. And this is what a standard code would look like. You just need to provide the data source. An example gen would start collecting data from that. And there are various types of data sources available. Best is TF record. If you are familiar with it, it's awesome data structure to work with. And you can just provide TF record, CSV. Only 2 are mentioned, but there are Avro and Parquet and other formats are there as well. And not just data ingestion, but it provides other functionality. Let's say if you want to split your data set in, let's say, 80-20, 75-25 based on a requirement, you have a data time series data, which is, let's say, spread on the different date format. You can just collect it step by step with these features. You can create a span of different data set, and you can create a version of a data set as well. As we move forward, data versioning becomes very critical after, let's say, code version. So yeah, this was about the data ingestion part. Moving towards the analyze. Oh, by the way, if you feel this is being redundant thing, you should feel happy, because this is what TFX is. TFX is built in a way that it seems redundant. It seems like, yeah, data ingestion समझ लिया, आगे का easy ही होगा. Because the code is simple. Customization is difficult, which we will not touch today because it's 45 minutes of time. TFX is something that requires an entire course for it. Right, so second is TensorFlow Data Validation. So, okay, imagine this is this part only, not the tuner, sorry. So example validator, schema gen and statistics gen. So as we are working professionals, we must be aware of something called as training, serving skew, data drift. Earlier, we needed a separate pipeline to build this, different set of libraries to understand whether there is a data drift is happening or not. With the TFX, we can actually integrate the entire functionality with the same framework over here, right? So, and it is pretty simple if by combining all of this. So, statistics gens compute the simple statistics over your data with just a simple syntax. We can do this with any libraries. The only difference is doing this with the NumPy is going to take your time. Doing with this TFX is going to make your life easier if you are working with CSV files. And the best thing is, let's say if I ask you a question from this slide, maybe let's see who can answer it. If I'm getting a less accuracy on this, let's say, taxi, I'm trying to predict a taxi fare, and I'm not getting a right accuracy when I'm trying to predict taxi fare in the early morning. This is a question, like this is a standard problem that you face. How can you look at your data set to understand why this problem is occurring? Your model is predicting pretty good in the different time zones, but in the early morning, it is not giving that much accuracy. So if you explore the data, you can see in the early morning, the samples are less samples, less accuracy. And in the normal daytime, we are having a pretty good much samples. right? So this was just one example. There are also a lot of other different questions which are based on data. You can answer it, but this is just for the example part. Schema gen. What schema gen does it creates a schema, simple as the name suggests. It helps your model to, let's say, accept what kind of values would be coming. If I write 1.0, it's a float number. It could be string as well. But passing 1.0 in a string is gonna cause a lot of error, right? If I'm saying I'm expecting an integer in this data field, and if I pass 1.0, which is a float, values are same, but data type is different. So to standardize that thing, we have a schema gen which helps us in understanding what kind of data are we expecting. And same goes with example validators. So what example validator does is, let's say you have this kind of text data set, जहाँ पे बहुत सारे companies के नाम लिखे हैं. अगर किसी user ने Zomato की जगह Zomato डाल दिया, and if you have some automation planned for that, it is gonna detect as a unique value, and it might consider it as a different company, just a difference of O and A. What this particular example validator does it tries to find this less than 1% values. It says that these are the anomalies, and it might be a mistake from user or from mistake in your data, and you can correct it. And believe me, all this with just one or two lines of code. So this is what power of TFX is. We might be thinking यार इसमें नया क्या है? Like machine learning पहले भी काम करता था, ये सारी चीजें पहले भी होती थी. The only difference is how easy it is to do it, how convenient it is, and how convenient it is to combine it with your existing pipelines, right? So yeah. So what schema gen helps you in high-level description of the data, like what features to expect. Oh, sorry. Yeah, what feature to accept, what value domain, what constants are given there. Second is statistics gen, data type inference, descriptive statistics. All of this in a couple of lines of code, you'll get it. And example validator, missing feature, wrong feature valency, training serving skew, data distribution drift, all of these things we can use from this library TFDV. And TensorFlow Data Validation library itself is not just limited to this. It has a lot of different features you can use for the all your different needs. But if you talk about standard things at an abstract level, these are the offerings. Second is transform. Feature engineering, one of the most important aspect of machine learning, and generally those who are in deep learning, they avoid this. Because हमको क्या सिखाया कि deep learning में जो deep है, वही features ढूंढ लेगा. Machine learning का जो machine है, तुम्हें उसमें डालना पड़ेगा feature खुद से निकाल के. But feature engineering is always needed. The more quality features are there, the more quality prediction you will get with a less of the training round. And one of the awesome thing about this transform is the way this is designed. Because see, if you are running a machine learning pipeline, statistics gen itana computation nahi demand karega jitna transform will demand it. Imagine you are working with the video files, 4K video files, and the amount of parallel processing you need to process a 4K video for a machine learning workload, right? The best thing is, it has a separate code file. You just write this syntax, transform, and you provide this separate Python file. You can modify this Python file whenever you want, as per your versions. You can use this Python file for a similar use case in a different domain. Or you can just individually scale this module. Imagine you just Dockerize a transform module. You can scale it to the 0 to n, a separate module. You don't need to scale an entire pipeline for that. Right? So yeah, this is a scalable data processing. It can apply to training time, and not just a training time. When your model goes into a production, the graph that has been generated by transform will go with it. So you don't need to write a separate code. And imagine like for model training, you have normalized the data, but for models serving, you have just forgot to add data normalization. It is not gonna give you the expected output, right? So it was a very vague example, but I'm just trying to say it, if you don't have a same code in your training and serving, things are not gonna work out, and it solves that particular problem. That the transform graph goes with training and prediction at the same time. Oh, by the way, am I going too fast, too slow? Okay, perfect. Because I know you guys, this is the last session. You are taking knowledge since the morning, so Sometimes our brain just got caught up, like, nahi ho raha hai bhai ab. Perfect. Training part, our favorite part, right? Sabse best चीज़ है. TFX provide their own operators to do every kind of data pre-processing and for the training as well. And you can design your own components as well. That's we'll try to have it in the next FS session. If I know like this much amount of, let's say, professionals are coming, it's going to be an awesome topic. And not just trainer. It has a utility to do hyperparameter tuning as well. You just provide a simple set of parameters which you want to try. Let's say learning rate, batch size and everything, and just provide which search algorithm you want to use. Grid search, random search, Bayesian optimization, that's up to us. Codes are pretty much simple. Like literally these are the codes. You just combine all of this snippet, combine the pipeline, that's your pipeline ready. You just run it, Airflow ke sath combine kar do, there you have it. And yeah, this also takes a particular, this module file, which has your main training code. So it can be a deep learning model, it can be a simple estimator, it's up to you. Whatever use case you want to try. And this can also scale independently. So the best thing that it provides a compartmentalization of each and every module. So you can scale it at your convenience, whatever module you want to use, depending on the business use case. And yeah, again, modular use case, standardized model training, hyperparameter tuning, distributed training. By the way, maybe I forgot to tell you, but in backend, this transform and TensorFlow this training uses Beam for data processing. And Beam is a highly parallel, let's say, tool to process your data. You can use TensorFlow's distributed training to distribute a training workload into multiple GPUs and hardware. And if your company is using GCP, if you combine this with Vertex AI, there's an awesome functionality to scale your training with the few lines of code. So those who are using GCP users, like regular, okay, 1, 2, AWS kitna hai? Yaar, great. But those who are using GCP, they would be able to understand. If you're using Vertex AI, TFX comes with it, and it is very easy to scale this up. Okay, test. Now, these two modules we are going to spend a bit of time. Professionals say इसलिए ठीक है, but अगर students होते I would have spent a lot of time. We always thought to test our models to just see accuracy कितना है. Like we do model.evaluate, 99% आ रहा है, very good. But is this the right accuracy, or is this the right matrix even accuracy is? So to analyze your model, there is a dedicated library, comes with the TFX, which is Tensorflow Model Analysis, which comes into this evaluator portion, and I have clubbed it infra validator. Okay? What TFMA does is, it takes your model, and it analyzes your model in a hierarchy of data. Okay, this is a normal thing to do this. The best thing is, once you get the output, and you visualize this in a tensor board, you can actually see in what kind of data you're getting what kind of output. So if we take a very small and vague example, let's say if I am training a model to identify cat and dogs. Okay, simple, बहुत basic, बहुत घिसा-पिटा example. For a test part, if I give you 100 images, and out of 100 images, there are 99 cat images, one is a dog image, and your model says that it's a, let's say, 100% accurate model. Or sorry, 99% accurate model. Can you trust that accuracy? Anyone, why? Sorry? It could be overfit, but fundamental problem is the test data. The test data at out of 100, 99 were cat images, one was a dog image. Right? So, you can manipulate any kind of accuracy with your test data. You can just literally change it to meet your requirement. But if you can visualize it in a way which slices your data into different classes and tells the accuracy on the basis of different class, cat mein itna hai, dog mein itna hai. But if you pass an image of leopard, isme nahi aa raha hai. So that's a great advantage for machine learning engineers and data scientists to evaluate their models on a, I would say, a very rich area on every class. And I'm just taking an example of image classification just to explain it. In the other domains as well, this model analysis provides this kind of functionalities. Right? Again, very simple to implement. You see this Trexie MV spec. You just need to provide the specs on what type of performance metrics we are measuring it, and what is the acceptable metric. And you might be seeing this model X2. So model validator also works. Let's say you have already trained a model and you are training another model on the TFX. It will take both of them if it is stored in the metadata, and it will compare both of them. Like which model is working best on which area, and it will give a clear analysis. So you can actually say that model version 2 is better compared to model version 1 because of these reasons. Right? So yeah, metric computation, slice analysis. If you're hearing this for the first time, slice analysis, do search it. It's a very different, not a different way, but a very beautiful way to look at your results. Fairness analysis and integration with tensor board. And infra validator. I particularly love this component, infra validator, because let's say I've trained a model. अब हो गया है 50 GB का मॉडल हो चुका है already. I'm training it, and I want to deploy it in some servers. How would I make sure that the infrastructure that I'm selecting, it is gonna be sufficient for this model, right? So that's a big question. Like what we do is, okay, 50 GB का मॉडल है, एक काम करते 100 GB RAM का मॉडल ले लेते हैं EC2 इंस्टेंस और उस पर चल जाना चाहिए. We don't care about network, we don't care about bandwidth, how much memory it can sustain, how it will scale. What infra validator does is, and it's gonna it takes the model, and if you're running this in a cloud, it creates a sandbox environment with the Tensorflow Serving. And it's actually serve your model in that particular environment. It sends some request. It tries to generate that results, like how your model is performing inside an infrastructure before pushing it for the final production. So how it can help is, it can help you in getting that minimum requirements that your infrastructure needs. Maybe sometimes we are overshooting the infrastructure. It doesn't make sense to run this cat dog classification on a, let's say, NVIDIA Triton. That's gonna cost you millions of dollars, like to a large scale, right? So, and that's why I love this infra validator component. It's been introduced recently in last 1.5 years. Earlier it was not there in 2019, 2020, but a very awesome component to use if you're adding it in a pipeline. Again, very simple to code. You see these 3 dots? Just need to provide your serving specs, like what you are expecting. That's it. It will take care of it. Yep, dependency check, as I explained, configuration validation, environmental compatibility, resource available, and same as production environment. So the sandbox environment that it creates, it's same as your production environment. Okay. Deploy. Pusher and TFServing. Anyone aware of TFServing? I guess there might be a lot of people. TFServing people who have used? Okay, 1, 2. Great. How do you deploy your model, by the way? Like, model to mil gaya, .pb file या कुछ भी आ गया. How are you gonna make that model available? If I'm a customer, if I want to use that model, how you are gonna convert it model from an API? Any ideas anyone want to share? Sorry? But how you generate that endpoint? So you're saying you deploy a model to cloud and you provide a URL. But you need to write a script, right, which reads the model, gets the data, process, and sends the model. Flask is something that a lot of people use, Flask APIs. Flask and Heroku, great. Okay, and we will come to that. If you are hearing about TFServing for the first time, you are really going to love it. But before that, let's just see about the component pusher. So TF models run on multiple devices. You can run a model on a computer, but if I want to run that same model in my mobile, that's not going to work. I need to convert it to a TF Lite model. There's TensorFlow JavaScript as well. So what this component does it, you can specify the path where you want to serve your model. It will push that over there. So if I have an automated pipeline, which let's say once the model is trained, it takes the model automatically and serves the model. And if I just provide the path to it, the pusher is going to convert those model and provide us with the API endpoint in a very simple manner, right? So this was the main gist of TensorFlow extended, but we are missing one part, which is a metadata store. Any idea why metadata store is needed? Some minor idea, not in this context, in the other context you can also like connect with it. But any idea why metadata store and what this particular component brings into the picture? Sorry? Preserve the attributes. Yep, true, preserve the attributes. Yeah.
Values which are not directly being used but being used internally between programs or infrastructure.
Okay. Yep, analysis. So, as you guys said, to preserve the values, to do analysis. So, all these components are working independently. I tell you, like in this the lines may show that this is connecting to this, but it is actually connecting to this. Then it goes this. That's why you can scale an independent component. All these components interacts with the metadata, collects the information from that, start doing processing, push information over there. So even once your entire pipeline has been run and you want to see what kind of things happen, if you want to check the artifacts of any, let's say, transform graph or the training logs and everything is available in the metadata store. So what you can do is you can actually compare your experiments. And the metadata over here provides that consistency that you need to make sure that आप जो भी experiment कर रहे हो वो एक particular sequence में कर रहे हो, right? So metadata is a game-changing thing that's been introduced, and this provides the consistency that is needed. Yep, simple. You can pusher. You can get TensorFlow Lite, JavaScript, TF Hub, or directly TensorFlow Serving. Coming to okay, till this point, going good. Any doubt, any confusion, me going fast? I just pick up some pace because I know you guys, I don't want to bore you with a lot of theory. You guys are professional, you easily can connect. Yeah. So obviously, serving is, you guys already know. I don't need to go over this, right? And this is simple, serving architecture. There's a client side which is taking a message, sending it to server, server processing, getting it to the request. We have done this with the Flask, and this is a very generic architecture. Forget about this. Important is how. Right? I'm not spending time on this because you guys already know this type of architecture. Like request response सबको पता है. There's not only this thing is happening, but important is how. If you write an API in Flask, how much time would it take? Those who have done it, any idea? 1 hour, 2 hour? You need to do some debugging, write a code, test it, put it to a cloud, and verify it. This is the amount of time you need to use TFServing. And one line is for installing, by the way. So you install TFServing. Let's say your train model ready. You just provide the path and the which port which has been exposed using Docker, and your model endpoint is ready actually, locally. And you can actually send a request to it using gRPC or REST API, and you'll get a response to it. This is how much easy it is to work with the TFServing, and it's not a prototype. It's a highly scalable, high-performing, container image, which you can use it for actual servers as well. Right? So let's say I see a lot of students in the hackathons, they build a model, they are very happy. Okay, 99% sir accuracy आ रहा है. And they're like, have you deployed? नहीं सर, वो दिक्कत आ रही है, Flask काम नहीं कर रहा है, version match नहीं हो रहा है, data सही से नहीं जा रहा है. It is taking time. You can just simply use TFServing over there. At least, for POC purpose, this can work really best. Even it can work in a production as well. And the infra validator that we talk about, it also uses TFServing to create that test infrastructure. Yep. But we all talk about this, tech. Tech only makes sense when it is creating a business value. I can come to you and I can say, hey, I have trained this transformer model, GPT 3.5. Do you have millions of rupees to support that? Your first question would be, okay, I can give you that money. Will I be getting that money back? If adding a machine learning service or a feature in your product is not making any sense to money, whatever rich technical knowledge you have, that doesn't make sense. At least in business. For personal satisfaction, it's always there, right? So, we talk about business impact. थोड़ा color issue है, but I can explain it. this is what's, those who are working with GCP, they might be knowing this diagram, but this is what, let's say, a full-fledged MLOps architecture would look like, right? There is a separation between experiment, deployment, and test, and there is, staging, and production server. What this particular part does it, this is where we play. Machine learning engineers, data scientists, software engineers, like I said, like big data engineers, everyone, they play into this part. They test different features. They try to get best accuracy possible. They try to make their model fair. Let's say once you clear that stage, you commit your code. It gets merged, source repository. Your project gets built. Now their pipeline goes to production. This entire production is built of TFX. You are using TFX over here. Same TFX goes over here. No clash between any kind of version, any kind of different tools, or let's say two different tools working together. You can just Dockerize entire pipeline for small use case. You can Dockerize separate modules for it. You can read data from different sources, be it cloud storage, local storage, time series data, be it let's say streaming data or anything. You can, process your data in whatever way possible, because ultimately it is backed by TensorFlow. And TensorFlow has humongous amount of operators available to do any kind of calculation you want to do. Let's say once your pipeline is here, you have a ML metadata. And let's say this pipeline is training your model, and once your models get deployed, it will be automatically deployed by TFServing. Right? अगर आपने Flask API use करा है और आपको पास नया model आया, so you need to put an arrangement to version that model and and automatically replace that already model which has been used and replace with the latest version. Let me just go a bit, take a step back. What TFServing does is, you see this file system? It already gives the ID to individual models and take the latest model with it. So you don't need to manually replace the, let's say, working model. If a newer model passes your test, passes the accuracy dependency, and it is better than the previous version, it will get deployed with it. And you can do A/B testing with it. You can do, red and green deployment, everything. So ultimately, when you translate it to a business fact, your team is working fast, right? You have a great developer experience, because developer experience matters. अगर किसी company में you are spending your time in doing tedious things which are not helping you to skill up, आप ज़्यादा से 1 साल काम करोगे वहाँ पे. If you are a patient guy, then a guy like me, I'll just 6 months. That's max. If I'm not adding value to my skills, and a lesser money to cost, because आपको चीज़ें change नहीं करनी पड़ रही. You are just enjoying that consistency of a tool. So in technical word, standard and consistency, efficient model deployment, scalability, improved model governance, hyperparameter tuning for optimal performance, everything, whatever we discuss. This all translate to two things: cost efficiency, faster time to market. You are reducing your manual work. You are automating it to do it by machines, which says faster time to market, right? And it is cost efficient as well. So this is something what TFX provides. So TFX is just a tool in the set of, let's say, larger umbrella of machine learning operations. But it's a tool that can do a lot of things, that can help you in a lot of different ways. And it can make your life easier. It can, let's say, upskill you. Almost all Google products uses TFX. Even Spotify shifted to TFX and Qflow, which are both open source and Google product. And Twitter, for let's say tweet recommendation, they use TFX as a backend, right? So it's a very powerful tool. TFX is relatively new compared to TensorFlow, but it has almost all the features of TensorFlow. So you have a rich library to work with. It is compatible with TF models. There are a lot of open source models available. You can directly use them, and you can like end to end. At least for, let's say, training and deployment, it works really great. So this was it. So yeah, if you want to connect with me later, you can just scan this QR code. And don't worry, you won't directly follow me. It's just a way to, I'm not just, scamming you to follow me. You can just connect with it. If you find it helpful, you can, on LinkedIn or something, you can just reach me out for any kind of discussion. Yep, this was it. I hope you liked this session. It was valuable to learn by you. Yep.